Dan, welcome.
Thanks, Danny.
How are we?
I'm doing pretty well, enjoying the weather up here in Glasgow.
No, thanks very much for coming on. So you are regional sales manager for Vast in the UK, which we're going to go into in some detail. So in a previous life, before Data Beta, I was a storage engineer. So storage is my background. That's I've had a passion in IT. That's what it would be. So when I first met you, we were looking at Vast as a new potential storage product. And I'm always a bit wary of when a new sales regional manager comes up to meet me to talk about storage. But within 5 minutes of talking to you, I thought, okay, this guy's different. You had a detailed understanding of it. So got to know you a bit. And actually, how you've got to this role is very, very different compared to the kind of normal sales rep role. So where did that start?
Yeah, it's been an interesting journey. So I just turned 51. And so if I was to summarize my life, my 20s, I was an engineer. I started out as a chip designer. I got a degree in electronic engineering. So I spent my 20s in the semiconductor industry, started designing chips, and then moved into a sort of an applications consulting role, so a pre-sales role for semiconductor software design. My 30s, that semiconductor background saw me go into a couple of startups. So I got involved in some US startups coming to Europe and helping them grow out the business. And then I actually co-founded a couple of startups of my own. One of those was a semiconductor IP company, similar business model to ARM, licensing technologies to others. And then I got involved in some consultancy work and got involved in some other startups. So my 20s, semiconductors, 30s, really startups, some of my own, some that I joined for other people. And then I found myself really at the end of that time, none of those startups were a great success. But I found myself working on a project which was actually quite relevant to some of the stuff that you do, which was I'd got involved in a startup doing data center liquid immersion cooling. The company was called Isotope. So at the end of my engagement with that project, I'd been working with a storage company, doesn't exist anymore, a company called Zyratex, and they'd asked me to come on board to help them figure out what their cloud strategy should be. And I didn't know a tremendous amount about storage, but I knew a lot about industry dynamic sectors, having done the startups, and they asked me if I'd help them figure out what their cloud strategy should be. So we looked at basically what they did, which was big disk-based systems. We looked at market opportunity, and one of the big opportunities we felt at the time was object storage, driving petabytes of capacity, and we felt that there was an opportunity there to build a product to address the market for service providers to stand up S3 compatible object storage as a platform. And so we started building that product. And again, that product wasn't particularly successful. Zyratex was sold to Seagate. And as part of that acquisition, the project I was working on got cancelled. And so it was a case, right, well, I'm in my 40s now, what shall I do? And so rather than go off to another startup, I was presented with the opportunity to work within Seagate to help them take the hardware platforms that they had to address different market opportunities. Traditionally, they sold only to OEMs who built storage systems and sold those as under various brands. And here was an opportunity to take that core platform and take it into different applications. So I worked with places like CERN to stand up petabytes of capacity under the software operating system they had. And I became a sort of a subject matter expert in things like OpenStack and so on. So there I am, beginning of my 40s, a trail of not so glorious exits from startups behind me, and now knowing quite a bit about storage from working on some major projects. And at that time, basically, I had been in that role for about 4 or 5 years. And it dawned on me that actually I was really enjoying getting out and doing the selling. I'd always been involved in selling in the startups, but as one of many hats that I was wearing in some of these businesses that I was running, I thought, actually, this sales thing's, I'm quite good at this. As you said, with that technical background, it helps me establish credibility, hopefully. And so I found myself basically looking at what I could do. I knew about object storage, found out that Cloudian, a company that I'd seen in the marketplace, was looking to grow in the UK, and I got myself a sales job there. So that was actually my first sales job. So I, 20s as a designer, techie, 30s doing startups, 40s I turned myself into a storage sales guy, and that's what I've been doing ever since. So here I am now in my 50s. I've got to figure out what I'm going to, in my story of my life, what I'm going to say my 50s were. But for now, I'm very happy in the role that I'm in.
So you're at Vast Data now. So Vast is one of the kind of poster childs at the moment. They've been recognised as one of the fastest growing technology companies of the last
not just storage, but technology infrastructure, IT infrastructure.
Absolutely. So there's a lot of noise, a lot of success from a storage perspective coming from Vast. So what's the success of Vast? If you just explain what it is, why are we seeing it everywhere? Why are we seeing the headlines?
So if I put it in a nutshell, what Vast offers is high performance, scale out, all flash, file and object storage. Now, other people have done all flash file and object storage. Other people have done scale out, but nobody has done it in the way that Vast has. And what Vast has uniquely been able to bring is, and a lot of people's feedback is that sounds great, must be expensive because it's flash, and that's where Vast has really differentiated, both through architectural innovation, business model innovation. We've been able to take flash, I guess where flash hadn't been able to go before, at least not cost effectively. So I'm sure we'll end up talking today, but things like the data reduction technology, the way that we intelligently use flash, it means that we can provide customers with an all flash platform that certainly on a TCO basis and maybe on an initial cost of acquisition basis can be directly competitive with far less performant, either hybrid flash and disk, or even in some cases, if the data reduction is high enough, even with all disk systems. So that's the really unique bit. It's about making flash for unstructured file and object data much more widely applicable. And there is a pent-up demand for that. Maybe people are surprised by that. And I suppose if you think of file and object in the context of a NetApp filer in the corner sharing direct marketing presentations between the marketing team, doesn't matter if they wait a millisecond or two longer to access that data, or even half a second. But it isn't about humans accessing this file and object data. The real growth is in machine applications, machines, scale out. I'm not going to say the AI ML buzzword too early in the conversation because it isn't just that.
Too late.
So I didn't I? But there are plenty of applications, distributed systems, high performance computing, Spark workloads. They all need fast access to large amounts of data. And that's a big opportunity. It's allowed us to grow in the way we have. But I don't know how many people are listening into this will have heard of Vast before. When I ask at the beginning of a first introductory meeting, I'd still say it was sort of 60-40 that until that meeting was set up, that the prospective customer at least, hadn't heard of us. So I think people in the storage industry are seeing the buzz, but I don't think that we're as widely recognized out there in the broader IT industry. But that's changing.
It is. Well, you're plastered across an F1 car now, aren't you?
We are, Williams, yeah.
Are they a customer?
Yes, they are.
They are, okay. So one of the areas where we're looking at Vast for Data Vita is for a certain type of workload. We weren't drawn towards Vast for a replacement of an app filer, although it sounds like it may be the case. Where are you seeing successes in, I guess, kicking out some of the traditional vendors? And why are customers, I guess, actually moving away? Because moving away from a storage product is actually quite a big choice. There's a lot of disruption, there's a lot of technology debt, there's a lot of training systems, interoperability of everything that goes around it. It takes quite a lot for someone to say, actually, the 5 or 10 year investment we've had, the emotional investment within this technology stack, we're going to put it in the bin and we're moving to this. What are the reasons that you're seeing driving that? So
until Vast came along with the ability to make flash affordable for all of an organization's data, the typical mentality of most customers, whether that was a high performance computing customer, whether that was an enterprise, whether it was life sciences research, the mentality, and understandably so, was we have to go build a hybrid system, as in we need to build a system to store our data in different tiers, typically. Maybe a small amount of flash that might represent 10, 15, maybe 20% of the total capacity, but would represent a disproportionately high amount of the overall spend. And then maybe 2 or 3 tiers of disk or hybrid behind that. And so that kind of works, if it ever works, for a certain class of data lifecycle where data is most valuable in the short term, and then it ages off and then eventually ends up cold and never being accessed. What we're seeing is a lot of customers are moving away from that. Maybe they never even really were there, but they couldn't afford to do anything different and had to tolerate the fact they had data spread across various silos and maybe or tiers and had to do the best to move data around. But there was a big opportunity cost, a big bit of technical debt associated with that. So what we're saying, what organizations are seeing with Vast is the ability to put all of their data, to consolidate and to simplify, eliminate tiering and also silos to make their data much more easily available.
Okay, I think one of the elements where, coming from a traditional storage ground, and I had to get my head around, as soon as I hear flash, you think that's your primary tier.
Yes.
And it's amazing how us dyed-in-the-wool techies are always trained a certain way. So you think, that's my primary tier, I've got my secondary tier, and I've got my archive tier, where you need to rip that methodology up and start thinking afresh. Someone saying to you, why don't you use your flash array as a backup target? You're instantly going, well, why would I do that? That's a waste of money. But during the discussions and our own due diligence we've been doing on the Vast array, it really is a viable option. So I guess in terms of one of the big differentiators that we've seen from a service provider's point of view, is that storage reduction.
Yeah,
which is massive. So we monetize storage. We make money from storage. So the greater reduction, the higher the profit margins are, or the more competitive we are in the market.
Absolutely,
There's two different ways that we can look at that. Now, when you first came up and you said the same thing, our DJ works differently, you got a heavy roll of the eyes.
Yes. Another one.
And I know they all work differently in terms of what we're doing. But I guess from our own testing of the platform, we have seen quite a drastic impact on that. So I think that is probably one of the key elements. So it's probably worth explaining, why is your dedupe actually different? And I guess it's more than dedupe, isn't it?
It is. So let's talk about data reduction rather than dedupe specifically.
Exactly.
So I think there's multiple elements to this. So first of all, I'll say that dedupe is a solved problem as far as block.
The algorithm, isn't it? Yeah.
So as far as block storage is concerned, traditional dual controller architectures, it's relatively easy to dedupe, because at the heart of a data reduction technology like dedupe are hash tables. So you need to be able to scan data as it's coming in and identify, have I seen this piece of data before? If I have, then I don't need to store it again. I can just store a reference to it, a pointer to it. And the way that we spot whether the data is identical to another bit of data or not is we hash it, and through mathematical calculations, if the checksum's the same, the data's the same. We don't need to store it. Now, that's fine in relatively straightforward architectures, scale-up architectures, and particularly, therefore, in the sort of SAN world, the block world, you've only got a couple of controllers to share that hash information with, and you need fast access to that because you can't process things faster than you can access that. Now, skip across into the file and the object world, then you've got distributed systems, typically scale-out systems. And most other vendors, unlike Vast, are what we call scale-out shared nothing. And in a scale-out shared nothing architecture, there are many limitations, but one of them is you don't have that global, fast, shared space in which you can store the hashes of all the data coming in. So at best, all you could do in a scale-out shared nothing architecture is take data that's landed on a particular node, scan it, and see whether it's similar to data that has previously landed on that node, as opposed to one of the other 6, 10, 20, 50 other nodes in the system. So it could work, but it would be very limited in scope, and its efficiency would be a large part in luck in terms of how the data being ingested into the system has been laid out across the system. So what does Vast do differently? First of all, we have an architecture that's fundamentally different. We are scale out, but instead of shared nothing, a bunch of individual nodes with limited communication with each other, we're scale out shared everything. Now, I don't have a diagram to point at to explain this, but basically we have a bunch of containers running on servers. We have a low latency NVMe fabric that connects all those containers into the fabric. And on the other side of that fabric, we have a bunch of drives. They sit in enclosures, but the enclosures don't really do very much. They just present the drives up into that NVMe fabric. So every container sees every drive. And there's a mix of different drives, but the area that we'll talk about here is some storage class memory, and that provides low latency, memory-like, non-volatile storage, and every container can see that. So the containers use that, we call the containers C nodes. So the C nodes use that global pool of storage class memory for a variety of things to make the cluster work. But one of the things they do is keep all the hash information there. So it's a global view of all the information. So first point is we do global data reduction. Other vendors can't do that. Architecturally, they just don't have the ability to share this large amount of hash data efficiently around the system. And then secondly, once we're actually analyzing the data that's been written into the system, we have a period of time while we're doing various other things in terms of the way we manage the right path to scan that data with a bunch of different algorithms. So yes, we'll do a traditional dedupe. We'll look for identical blocks of data, and that's an easy win. We can, with the hash, we can basically say, it's the same as that. We'll just store a pointer to that. But what we're also doing with the scanning is we're applying a different type of hash, a similarity hash that doesn't say this block is identical to that block. It's this block is quite similar to that block, and therefore it's worth our while spending some CPU cycles to reduce that together. So I guess to summarize it, we do global data reduction, other people can't, and we apply some quite innovative data reduction technologies that isn't just dedupe. And one of those is similarity. We also have some data-aware compression algorithms as well that can look inside file formats and so on and make optimizations. But the key point at the end of all of that is we're finding data reduction where typically other vendors cannot. So obviously, I always get that roll eyes, whether it's from somebody in the industry or from a customer. If the customer's heard of data reduction, they've also been jaded by it, by some other vendors' broken promises. So we've got about 10 exabytes of storage now out in the field. We've been shipping for sort of coming up 6 years now. So in that time, customers have stored pretty much 10 exabytes of data on vast platforms. Now, not all of those systems call home. Some of them are in big dark sites, national labs and things like that, where they're not allowed to call home. But there's a significant proportion of that 10 exabytes calling home. And we get to see what the data reduction is. And that the global average across exabytes of data is 2.5 to 1. Now, 2.5 to 1 may not sound like a lot relative to the 20, 40 to 1 you might see on a VDI or a VSI. But this is the sort of work, different workloads, unlike, the same VM image stored over and over again, where you get the great dedupe on typical block workloads. But that 2.5 to 1 is typically enough to take an all-flash platform, which, by the way, isn't using the most expensive flash on the market. We're very cost-effective with the flash that we do use. So that 2.5 to 1 is typically enough to get you down a 2.5 to 1 to the price, I would say, roughly of a customer with a tiered system of 20% flash and 80% disk. So what they're able to get at 2.5 to 1 is an all-flash system with all-flash performance for all of their data, instead of a system where they would only be able to afford 20% flash and 80% disk. Now, in vast marketing, we talk about flash for the price of disk. Extinction events for HDDs was one of the early marketing taglines I remember reading when I joined. And absolutely it can be, but you have to have that higher level of data reduction. So, 2.5 to 1 fits nicely with maybe 2080, and over time we see that improve as flash economics continue to improve. If I get 3 or 4 to 1 data reduction, now I'm really down into the price of high-end nearline SAS drives. And if I got 8 to 1, which we do get, some customer data sets get 8 to 1, then I'm down at the price of SAS disk, really, in which case, why wouldn't you store on an all-flash, high-performance, super dense, power-efficient system?
Absolutely. And being a service provider, we're a great stress test for this type of marketing, because the technology almost comes second, because we assume the technology is going to work. That's one of the main aspects. We tend to deal with the kind of tier 1 vendors, so we're not in the kind of open source and the kind of bleeding edge of what we're doing. So there's a certain assumption if we get an enterprise vendor through the door, it will work. We still do all our testing and due diligence on it, but we assume it's going to work. So then it comes down to a cost model. How can we productize this? What advantage can it give us in the marketplace? So what we have identified with Fast is that there's 2 real main workloads that we are looking at it, and they're distinctly different. So we're actually looking to deploy it for backup data, which again, that wasn't the primary reason of why we started looking at it. But again, there's a common misconception, especially from my point of view, that once you had a backup software had done its own compression and written it to disk, that was you. That was as good as you can ever do. But from our own testing, we are starting to see 2 to 1 reductions on top of the vendors' reductions from what we're doing. And it also gives us the ability to back up really, really quickly and restore really, really quickly. The other workloads that we are looking at it for is the really problematic ones. So super high performance, where you need exceptional levels of performance. Now, typically with those type of workloads, I shouldn't say this, but they aren't often backed up, or they're not backed up in the traditional way that enterprise are, because the rate of change is too great and the scale of data is too great. So if you ended up saying, well, we're going to keep, if we were going to do a normal differential backup on these really high performance dynamic workloads, you would end up, your backup storage would be 10x the price of your actually primary cluster. And VAST solves those two workloads. So I guess going back to using it as a backup target, because that is really the dirty end of the market, where you're thinking...
Is that where you think you're going to be selling when you're selling an all-flash platform,
no,
is it?
It's not. One of the aspects we are really impressed is as well with the ability for it to dedupe things like MP3 files.
Yeah.
For instance, these are things. So the dedupe is different. In compression,
it's different.
It is different. One of the terms that rings in my ears from what you said is that being AI ready.
Yeah.
And I think personally that backup data is going to become really, really important for the future of organizations, where companies will train personal models based on their own backup data. You might have 7 years worth of data, so why not train your own model within it?
Yeah.
Then you can get insights, you can interrogate it, you can look for trends, you can do all sorts of stuff. I've actually heard of one organisation is actually using their backup data from a compliance point of view to say, based on our document security matrix, how many of these documents have actually been emailed inappropriately, and it's given that level of data. So we've got a backup target now which is cheap, service providers we care about, but is extremely quick. So that then opens up the door for us to start looking this AI ready or future ready.
Yeah.
How can we best utilize that? So I guess from your customer's point of view, it's trying to educate them, saying look what's coming rather than look what you've got.
Absolutely. Ultimately, we're offering to customers a price, performance, simplicity set of benefits, and if the data reduction is great, then the price drops relatively, and then maybe the customer doesn't need such a driven performance requirement to justify an expenditure on an all-flash platform. Sometimes the data reduction might not be there, but nonetheless, we're still a very cost-effective all-flash platform, and therefore, because of the performance and the simplicity, they'll go with us. Sometimes we have customers just talking about a traditional enterprise NAS workload. We've got a customer in England, former utility or former national utility, that has basically switched from a fairly typical traditional enterprise NAS across to a VAST platform. Now, they don't need that performance today. That's primarily working with users sharing data with one another rather than machines sharing data with one another. But because of the data reduction, because of the simplicity, and they've moved across. They're in the process of migrating over from a traditional enterprise NAS to VAST, replicating pair of systems. But why did they do that? Well, cost was pretty good. Made sense economically for them. The TCO was good. The 10-year life cycle that we can offer on existing hardware investments all made sense. But the key point was that they were making themselves future-proof. AI ready is a great phrase, because they don't know exactly what they're going to need to do with that data, but for no additional cost, they get a platform that gives them that insurance, that future-proof insurance, really. So they can run machine learning models against old customer data or records of their network and things like that. It's all there. It's available. They don't know yet, but what they do know is that
it's coming.
It's coming. Something's coming.
Yeah.
And they have a platform now that will be able to accommodate that, but was not substantially more expensive than just sticking with a renewal of what they already had, which would have been much, much slower. Yeah.
And one of the other things as a service provider we've started doing, it's changed the conversation. So we are now speaking to the likes of FDs to understand how technology is monetized. So if we look at people who are processing data, animation houses, we're actually now having a commercial conversation about, with the benefit of VAST, how more quickly can you do this job that actually ends up making you more money, and the same thing. So it's making the whole TCO move up a level. So rather than saying, what does it cost to run and what does it cost to manage, the TCO model is now, can you 10x?
Yeah, it's like an ROI more than a TCO. So so absolutely, historically I've done many TCO models over the years for customers. Basically, you're saying, look, okay, it might be a bit more expensive, Mr. Customer, but look over the long run with power and cooling savings, it works out cheaper. So make the investment. That's oftentimes what previous employers have looked to do. And of course, we can provide that TCO benefit as well, driving cost out. But to your point, there is a benefit in many organizations, either quantifiable today or certainly in terms of that future-proof capability, where you can say, okay, you can save money over here on the compute, you can get jobs done quicker, more quickly. And that means that you can generate more revenue or minimize time to revenue from the investments that you've made. So yeah, it definitely up-levels the conversation.
Mm-hmm. And with those type of data sets as well, when you're speaking to the business, a lot of these organizations have just accepted the fact that there's limited data protection options for them. And they basically assume that risk in terms of it's not commercially viable for them to fully protect the data. So they always have some sort of batch job running or some sort of awful snapshot process running. What we've been able to, again, put into that ROI model is about the protection that is inbuilt into the platform, the ability to do snapshots, the ability to do replication. It's zero cost and almost zero performance impact as well, where you're now able to offer a level of protection, especially against ransomware and the likes, for these very dynamic and high volume workloads.
Yeah. So snapshotting, obviously snapshots aren't backups, but they are a good way of protecting data. And certainly, if we look at the reasons why people might be backing up, the inadvertent deleting of something, snapshots are a great way of protecting that, or inadvertently saving the wrong copy. With our SMB presentation, that looks like a Windows previous version. A user can go in and just, if enabled, roll back to an earlier version of a file. So that covers that use case. In terms of a bigger issue affecting a data center or a large chunk of hardware, the system's very resilient, but nonetheless, take out enough hardware, and you might have an issue. So they're taking snapshots and then replicating those either to another VAST system or potentially to an S3 object store, whether that's something in your data center on one of the other service offerings that you have, or off to AWS or whatever. That gives people the ability to store separately. So yeah, I think snapping and replicating is, to be honest, I don't think I've got any of my customers today in production backing their data up with a traditional backup application.
It's cost prohibitive.
It's cost prohibitive. Yeah. Although ironically, as you said earlier, we do have customers backing up to us because it's very cost effective and extremely performant to back up via a third-party backup application to a platform like VAST, and you get that.
I'm still trying to get my head around how my backup target's almost also my highest tier of storage. It does sound comfortable. So NVIDIA, they are clearly the poster child of the AI movement. Their CEO was up like a rock star.
I was at GTC. He literally had the whole entourage around him. It was quite funny to watch the security and the hangers-on. Amazing.
I know. It's absolutely incredible. The takeover of the geeks.
Yes.
Long may it last. But VAST is quickly becoming the storage of choice for AI. And one thing you've said a few times within the podcast, and I think it's well worth kind of resonating on it a little bit. Machines talking to machines, that's what we're preparing for. And that's a world we're already in, but again, there's going to be an exponential development of it. So why is VAST going hand in hand with the AI movement? Because in terms of a lot of the biggest noise coming out is about VAST's ability to integrate with the AI world.
Yeah. So I think it's worth sort of looking back historically. Historically, the world of storage and data was massively dominated by like OLTP, Oracle databases, stuff like that. And so it was all about how fast you could be on a small transaction, because you basically need to keep that Oracle or that SQL Server transactions happening really quickly to manage your your financial system or whatever it might be, reconciling bank accounts and so on. So data was all about the data value was in the speed at which you could process a small chunk of data. That individual piece of data, then its value just sort of drifted off over time. Whereas in the world of machine learning, data gets more valuable, or larger data sets are a lot more valuable than smaller data sets. The key thing about machine learning really is historically, to create a smart algorithm, a smart piece of software, it was all about a smart team of software developers capturing their collective knowledge and writing code explicitly to do that. With machine learning, obviously you've got models now, transformers and those sorts of model frameworks that have been developed by some very smart people. But then the results of the machine learning training are really down to the quality of the data and the volume of the data. So what does that mean? You need a lot of fast storage in order to shift large quantities of data through the machine learning training algorithm. So that's where we come in. We can store petabytes upon petabytes of data, and unlike a tiered system where you might get fast access to some of the data some of the time, with Vast you get fast access to all of the data all of the time. Actually, with machine learning, one of the problems is overfitting. So you end up, rather than having a very predictable sequential reading of training data sets, where potentially the model will learn incorrectly that there's some dependency between the series of the things that it's seen, then you end up needing to have random reads to the data, and there's no way on earth you can prefetch a random read. You can't break the laws of physics. If I want to read something that's sat in the 20% of my storage system that's disk, then that's a cache miss to all intents and purposes. So I've now got to wait, and that's just going to massively slow down the performance of which I can complete my training job. So long story short, machine learning needs fast access to large amounts of data, and because of what we've put together, not only do we provide that fast performance, but an often overlooked bit of the machine learning environment is the actual training bit itself, the kernel, if you will, of the bit where you're basically pushing data through a series of training epochs through a model. Before and after that, there's a whole bunch of other processing, and Vast does file and object. So the NFS workload that might be going through the training might have originally arrived as S3 and might need visualization in an SMB context afterwards. And when you zoom out from that very important bit in the middle, which is where all the buzz is at the moment around the GPU training, there's a huge amount of data processing that needs to go on either side of that. And it's the completeness of what we offer, I think, in particular, that's really relevant. There are other vendors that can give you a small amount of fast storage that just needs to attach to the GPU cluster to run that training job. Zoom out, there's nobody that can do that end-to-end piece in the way that Vast uniquely can. And so we're seeing some, we've announced people like CoreWeave, Lambda, some of the largest deployments for GPU clusters, cloud service providers in the world, and they've all chosen Vast. Now, not all of them chose Vast to start with. In fact, there's a nice little video on our website, or YouTube now, from the CTO of CoreWeave. And I think his opening statement was, I told Vast to go away 4 times before I let them in the door, because they hadn't thought through or hadn't experienced firsthand from the customers using their platform the fact that the data isn't just that little bit of data in the middle, the training data, it's the whole piece. And it's when people understand that they really realize they need a platform like Vast.
During the training phase, are they using the space optimization technology in terms of, are they deduping data, are they compressing it, or at that point are they just trying to run it as quick as they can?
Well, for us, the dedupe and compression, the data reduction is happening anyway. So yeah, there is some that happens, but that would be happening either way. So yeah, it helps a bit. It's interesting when you look at so NVIDIA have their SuperPod architecture, and if you look at the SuperPod architecture, it specifies for a given number of SUs, so basically compute units, a certain performance requirement. It doesn't really specify capacity anywhere. So there is a performance criteria set, but not a capacity criteria set. So a customer could, in theory, for a certain number of SUs, specify a tiny amount of storage that as long as it hits a certain performance requirement. And we do sometimes get shown RFPs for that sort of thing, but our response will always be, well, that's all well and good that if you're looking for a very small amount of storage for that training bit there, but what about the rest of it? And we're actually running a bunch of workshops over the next couple of weeks. We have a team that have been working with a lot of these big CSPs, and we're really talking about what the full data services catalog would look like from end to end, and how that can be monetized. So we do a lot of work with service providers too to help educate, because I think we are on the forefront of this. We are being engaged in a lot of these very, very large projects. We have customers today that are 200 petabytes in a single Vast namespace, but we're talking to customers at exabyte scale, which is just mind-boggling. That's more mind-boggling than using Flash for backup, I think. Yeah. But yeah, exabytes of all flash. And yes, at any given point in time, some of that data will be going through the training, but there'll be a whole bunch of that storage which is being used for both the pre and the post-processing of the data as it's kind of the data pipeline that ultimately leads to the business outcome that the organization's looking for.
I was speaking to another vendor who had a very strange view on training of data. They thought once all the training's done, there won't be a need for this exponential growth of storage anymore. But in my view, we've not even had the tip of the iceberg when it comes to it. So organisations will want their own private models. That's a given. They're not going to upload it into ChatGPT and let everyone search it for them. So there's going to be a growth on that. But I think we need to understand when you train a model and it becomes more intelligent, all it is going to do is then generate more data directly or indirectly.
Yeah, and I think just to carry on from that, inference as well. So you have a trained model. Now that trained model is still going to be processing data, and of course it's not like there's one Uber model. Okay, with ChatGPT, right? There's instances of that, but an organization trains its own model, other organization trains its own model. There are going to be multiple models, and each of those is going to be handling I/O. It's going to have queries running against it. It's going to be generating output. So inferencing and doing things with those is also a massive generator. So training in itself is probably just the tip of the iceberg, really. There's certainly in terms of that local scratch, and then there's obviously the data set that it was trained on. But yeah, inference we think is going to be absolutely massive, and that will just get pushed out to many, many more data centers. At the moment, we're seeing, some big consolidated, like hundreds of megawatt data centers going up, really, to provide a few very large organizations with the power to power a few very, very big GPU clusters for some of the primary model training. But yeah, that's kind of a hub, and then there's lots of derivatives off of that. So yeah, I don't think we've even scratched the surface yet.
No, absolutely not. So one of the things that again is very important to us is sustainability. So with Data Beta, we have a real unique approach to sustainability right from the ground up in terms of how we operate our data centers, where we select them, all the way up right through our supply chain. So as part of the procurement or the evaluation of the technology, the sustainability piece was really interesting. Now, I think one of the unique things about VAST's approach is the life cycle of your hardware. We basically assume that hardware gets refreshed every 5, maybe 7 years. Then you have to put it in the bin. But I guess one of the biggest reductions from a sustainability point of view when we were doing our calculations is your hardware supported for 10 years, which might actually be 2 or 3 hardware refreshes going in with. So from a sustainability point of view, there's a few different elements, isn't there? There's the hardware piece in terms of where
the embedded carbon,
embedded carbon. But I guess then it also plays back into the overall efficiency, the
operation efficiency, absolutely. So yeah, just to elaborate on that a little bit. So VAST, we consider ourselves to be a software-defined storage platform. We develop software. We don't create custom hardware. We don't build ASICs and the sorts of things that storage vendors of old might have done. But unlike many other software-defined storage vendors, we don't leave it as an exercise to the customer or an integration partner to go buy some commodity hardware. We've always wanted customers to have an enterprise experience, like they were buying an appliance. And to all intents and purposes, they are. So with the VAST supply chain, basically, when a customer orders a VAST system, the hardware is configured. There's basically a hardware compatibility list from a very limited number of choices, and that hardware is delivered. And that doesn't pass through our books. So all the software, all the revenue numbers we've ever published are just covering our software and services revenue. So the hardware passes through our channel partner, it gets delivered, our software is installed. And from that point onwards, from the point when our software has been installed, we take full responsibility for the hardware. We're not actually licensing hardware, providing a subscription to what we call VAST Gemini services. And that covers the entitlement to use the software, the support for the software, and for the hardware as well. So the only requirement we have is that you replace that hardware at least once every 10 years. It can be at any point you want within the 10 years. But, from let's say you buy it with initially 3-year support services contracts, then year 4, year 5, year 6, you can continue to renew that. We're not ratcheting the price up on you. We're not coming back to you to say, oh, well, we could extend support on that, but it's going to be ridiculously expensive. Buy another one instead. Classic storage vendor play. we'll say, okay, fine. Well, you paid that price per year for the first 3 years. So that's your price to renew it for year 4, year 5, year 6, year 7, and so on. And at some point before year 8, we ask that you replace the hardware. We're not going to restart the software services contract. We'll just allow you to roll in new hardware. We'll migrate the data. We can roll out the old hardware. And you've got, without any disruption, continuous availability of the storage services to the users of the platform. And potentially you've sweated that initial hardware investment for 10 years and eliminated 2 or 3 refreshes that would otherwise drive yet more embedded carbon consumption. So that's one bit of it. And then the nice thing about Flash, unlike spinning disk where you've got to pay almost all of the energy costs to keep the disks spinning, the hundreds of disks spinning at 72 or whatever, 5,400 RPM, going to pull 8 watts or something like that per spindle. That's pretty much a fixed cost. So unless you power it off, it's going to be drawing, IOPS cost you a little actuator head movement. Doesn't really cost a huge amount in the grand scheme of things. So basically your costs are pretty much fixed and 24/7. Whereas Flash, the power consumption is much more proportional to the IO workload. A system that with no reads and writes is going to draw less power than a system with a few reads. Writes are where the power consumption peaks up a little bit. So you're only paying, there is a certain baseline, but you're paying much more proportionately for energy, electricity, for a system that's being used and doing additional useful work rather than just sitting there storing the data. And then going back to data reduction, currently our densest platform in 1U, so I talked earlier about basically disks in shelves and switches and servers. So we have a 1U building block for the disk shelf, which has 1.35 petabytes. Wow. Of raw Flash capacity in it. So after our internal protection overheads and so on, in a typical system, that could represent 1.2 petabytes of what we would call usable capacity. So 1.2 petabytes in 1U, drawing that the cost of the energy cost, so that's about 800 watts typically, might be lower, might be 500 for a less heavily used system, might peak at about 840 watts for a large system. 840 watts even at max for 1.2 petabytes is pretty good, but that's before you add data reduction. So if you apply that 2.5 to 1 data reduction I spoke about earlier as our global average, then your 1.2 is about 3 petabytes of capacity. 3 petabytes for 800 watts. That's pretty good going in terms of the energy efficiency of the platform. So, feed that into a TCO, feed that into a carbon report. It's, we have got customers, some of our bigger enterprise customers, who take that element of it very seriously when making a decision on what storage vendor to go with.
It's becoming more and more important. I still don't think it's as important as it should be. A lot of people claim to be making sustainability first choices, but ultimately it's down to other factors. But it is moving up. It certainly is moving up. Where wouldn't you use Vast?
So, as I said, ultimately, if the data reduction is high enough, then we could be as cheap as SATA disk, effectively, like tier 4 archive storage. But that's, 8 to 1 data reduction. Tell you one really interesting area where you do get it. I know this isn't answering your question, but log data. A lot of customers, we have a lot of financial services customers, not traditional banks, although we have some of those too, but big hedge funds doing lots of systematic trading. And the primary use case that we have with them is they store market data, tick data, that they use to train their trading algorithms. That's a really interesting use case in its own right. But what they also do is they log and monitor potentially very large estates. Log data, because it's so repetitive in terms of its format, we typically see 8 to 10 to 1 data reduction on that. So in that case, going back to my earlier comments about where that fits, you might as well put that on Vast and get the ability to analyze those logs really, really quickly than stick it on basically a cheap SaaS type platform, really. But where it doesn't fit is obviously if the customer doesn't need performance and the data reduction isn't there, then you've got a miss, basically. So
if you're competing against a workload that's fully encrypted and they want to run it on a GBOD level cost, that's not Vast.
That's not Vast. Yeah, we can't do very much with encrypted data. And if they don't need performance and they're happy with the performance of JBOD SaaS or whatever it might be, then yeah, that's not a fit. Also, from Vast perspective, our typical customer size is average customer size is typically well north of a petabyte. So for me, customers with a couple of hundred terabytes, They might be a fit, they might not be, but we're not going to be knocking on their door. That, you know, by all means, they can come knocking on our door, but you know, that's not how we're a very small team generating very high revenue numbers. You know, not just in the UK, but worldwide. That's our profile. You know, we're still less than, I think, 800 people worldwide. Now, a fair chunk of those are in sales. A lot of them are in North America. But yeah, relative to the amount of revenue we do, you know, we're punching well above our weight. So I think that's just sort of as an aside, I think a great opportunity for Data Vita with the enterprise file service offering, because you know that democratizes, or that's perhaps too fancy word for it, but it opens up the possibility for other people to take advantage of this without necessarily needing to stand up a platform. Absolutely,
we've seen the absolute benefit of that, of being able to take the technology to customers where there's no way the model would work given the size of data, but we are able to aggregate all those customers together and deploy it at scale. So it really works going forward. One of the and I keep going back to backup, but one of the use cases that you were speaking about is one of your other customers, financial services customer, big Commvault user.
Yes.
And now that again is a really, really interesting use case.
Yeah. So they are a bank, actually, rather than a hedge fund. They're not in the UK. I won't say where they are because it probably identify them too easily. But they're in a part of the world where they're perhaps geopolitically a little bit more aware of the risks, both physical and cyber issues. And so for them, backup isn't an insurance policy against an array going down, or you know, a user accidentally deleted something. They're seriously concerned about a major impact to one of their data centers. So they're constantly backing their data up, and it's an insurance policy probably on the basis of a when, not an if, they'll need to ever use this. So they're constantly backing up and restoring into dev test. They're doing all sorts of things with the platform. They came to us with the challenge that they needed to be able to back up continuously at 20 gigabytes a second. Now, gigabytes a second is not the sort of number you typically hear with backup, but that was their requirement. And they were, as you said, they were a Commvault user. Historically, when performance was less of an issue and they cared about the same thing that most people were trained to think about, which was backup windows, RPOs. Can I back up within my window? Yes, great. Move on. Find another next most important job to focus on. Whereas now, the RPO is critical because that's basically, obviously, the point to which they recover. Hence, they're pretty much continuously backing up, very, very high frequency throughout every single day. And then also the speed to restore, because if they do have an incident, then they're going to want to recover their environment very, very quickly. So their primary requirement was backup, because that was the speed at which they thought they would, you know, the limiting factor. They wanted to hit 20. They thought their infrastructure could support that. Turns out it could. And then we've also been able to, so we hit that 20 gigabytes per second backup speed. And we've also been able to give them 100 gigabytes per second restore speed, which is just mind-boggling from a recovery perspective.
Absolutely is.
I don't think they'd be able to actually rehydrate their primary storage systems at 100 gig a second, but we have in a test environment shown them that they can do that. So yeah, it was an interesting one. It was relatively early in my time at Vast. I didn't come here thinking I'd be selling Flash for backup either.
I didn't think I'd be deploying Flash for backup either. So.
But yeah, so it's all about speed of not so much backup, because there are other products that back up quite well. You know, Datamain quite famously has both dedupe and fast backup speeds. You know, they back up into effectively a cache, right optimized cache. But the speed of restore wasn't really a design criteria back then, and it doesn't perform very well. We have customers who have, you know, been happily hitting their RPO, but when they've tried to do a full recovery, not just one file, but you know, restore hundreds of terabytes, petabytes of data, you know, the progress window is basically reporting weeks, if not, well, in some cases, pretty much infinite amount of time to restore that, and that's obviously not tenable, because you'd be out of business in most industries if you were relying on your recovery to get you out of a massive, you know, cyber or whatever other incident that you're trying to recover from. So yes, write performance is important, backup speed is performant, but restore performance is turns out is now increasingly important too.
Yeah, absolutely. Before we finish up, I always like to ask one more awkward question. In terms of future trends, what should we be aware of? What do you see coming in terms of, particularly with the use of storage, with the deployment of AI? Is there any particular trend? Or
I think I touched on it earlier, which is inference. I think that we're still very early in the grand scheme of things when we look back in 10, 15, 20 years time in the training phase. But I think that what we'll see is inference and edge to cloud type things happening even more, because, training is relatively easy for us to conceptualize that, there's a model and there's a bunch of data and you need to push that data through the model to fine tune its parameters. Now you've got a trained model. Great. But that's a thing that doesn't do anything unless it's got data being fed to it and it generating data. And I think that as we see the benefits coming through from these large language models, these other large models, what we're going to see is that impact everyday life. And that means that storage and processing is going to proliferate even more than we already have. We already carry around, what they always say, it's more in our pocket than probably 10 times, if not 100 times more than man landed on the moon with. But we're going to see even more compute going out to the edge. And I think that will be, from a storage vendor's perspective, very interesting, and from a service provider's perspective, very, very interesting as well.
Yeah, no, absolutely. So, Dan, it's been an absolute pleasure to speak to you. Get my storage geek on. It's always good. So I appreciate you coming on. Thanks very much.
Thank you.